IPEP.
We'll talk about it. All right.
That's incorrect, partially correct.
I'm missing a
essentially correct.
detail.
Oh, at least someone listened. Thank you, Braden.
I yapped for like all this crap, and I still.
Bad.
Wait, no! Oh my gosh.
Spriggan,
Computer again.
Which one is?
I met-
Yesterday. And we
They're
were walking
good.
back.
Like,
I'm
no,
watching
yeah.
back again. I gotta go pee. So,
No,
I'm just having a
Mr.
first-
Kennedy. Oh my gosh, I'm
Maybe
I'm gonna
What,
eat
Michael?
this paper. I'm gonna eat this paper.
What? Why?
nothing, never mind.
Yeah.
Okay. Hey guys.
So you.
Hey, listen.
Okay. I'll
I
get
need
to you in a
y'all to
second.
go ahead and hear me right here and right now. Learning is a process that does not stop. That is something that we have to investigate mistakes on. If I tell you what it's out of, that's all you care about. I want you to look at the feedback I gave you so that you can improve. Heck, I'll even say this. You look at your FRAIR models, I didn't put a single grade on your FRAIR model. What's the only thing I put on the FRAIR models? Notes, feedback, so that you can improve it and resubmit it when it's test time, okay? So, I am always going to give you feedback, that's the priority, okay? You will be able to see what your final grade is once I put it into PowerSchools. But, I know that the norm is to think about grades, especially when we're AP students. The priority, though, is learning. You learn from me, you will be fine. Yes, Lana?
I don't have a question.
Okay. You don't have a question? I thought you raised your hand earlier.
No, oh yeah, I wanted you to tell me how many points this
Yeah, I'm not gonna tell you right now.
is. What is E?
What's EAP again?
Essentially correct, partially correct, and incorrect.
E was what?
Essentially correct.
Essentially correct.
Essentially
Like
correct.
that.
Essentially
So is
correct.
that full point or half point or like three-fourths of a point?
Well, there's only three options. Essentially correct, partially correct, incorrect.
I assume it's fully
So I
correct.
just
Correct.
P is like 0.5.
Okay.
Ish.
It is.
Yeah.
So what's
The AP stats exam does weird things with EPs and Is, but yes, for the most part, an E means you got it essentially correct, a P means you got it partially correct, and I means incorrect. And it's especially wherever we see an I, if we see an I, that we need to investigate and learn. And we will be going over this demonstrated understanding so that you can improve before the test. Yes, Sanai.
I didn't class. Can I get another one so I could like add the notes to?
Sure.
Thank you.
Yep.
What happens if there's no letter? Oh wait, is it pencil?
Oh yeah, so some of them Ms. Kowalski did,
Oh.
and then we talked about, she wanted to do it in pencil, and I forgot to go back and put it in pen.
Okay, sorry.
Nothing.
No, yeah,
I'm
but
gonna
we
give you
talked
the wrong
about
grade.
them and discussed them, but she was like, I won't feel comfortable putting pen on here. So if you got neat handwriting on yours, that was Ms. Kowalski. If you got crappy handwriting, that was me. Alrighty.
Is that why I can't read this?
Correct, Michael. Just like I couldn't read your stuff.
Oh, whatever.
Huh?
What's
You
this?
know my
I
prayer
don't know
model
what
was
that is.
lit.
The numbers in the corner.
You made it.
Oh, the number in the corner?
Yeah.
Oh, that was to help me tally up points. If you look at the two numbers, they add up to what your final number was.
Thank you.
Yeah.
What was the other one?
I didn't tell you. Stop asking.
You said
So-
24.
Huh?
I thought you said 24.
I did not.
No, you said 20.
How many points did you
But
get?
there are 4 baked in
It's
points.
out of 100.
Is it the grade book?
What?
Say again?
Is it the grade book?
It's not in the grade book yet. How about we focus on learning?
No.
So, we will go over that soon. I need y'all to pay attention to explanatory and response. So, let's go back to, so to get to explanatory and response, let's talk about, nope, that's frozen, you can't see. Let's go back to where we were yesterday, and then we'll look at the DYU. So we're gonna do the analysis of the demonstrated understandings. Then we're gonna look at the proficiency scales to help us look at elements. Well, I guess I'm flipping this a little bit. Well, these are the things we're doing now, overall. So let's actually talk about this really quickly. This will help us get there. So in a long-term study, researchers collected information about the diets of participants and whether or not they have developed the eye condition called age-related macular degeneration, AMD. People who ate lots of green leafy vegetables, which are high in lutein and whatever that is, had a lower risk of AMD. So here's what I want you to do. I want you to go to your vertical surface with your group and quickly, let's say less than 5 minutes, answer A, B, and C to the best of your ability. This will help us answer these questions. Did you say unacceptable? Yeah, nice.
Yeah, he wants
Wait,
to
so
get
what's
you over
the
there.
other?
I never told you.
Well, we need to.
Oh no.
You want
You better get used to me not telling you
Mr. Kenny,
immediately.
you want
Well,
fours on
that's
the
wrong.
chalkboard, right?
Huh?
You want fours on the
Yes, fours on
chalkboard?
the chalkboard, please. But talk with your group as you try to figure these ideas out. So we got 4.5 more minutes on the clock.
Observational study.
Hey, you know it's in the notes.
Wait,
Pages,
what
right?
is that?
Hey guys, this is in your notes pages.
They didn't do anything.
You have.
Oh,
They just
that.
absorbed, they didn't tell them eat more green, so eat less. They just absorbed this, they just let them do it.
And can it still have an
Because the questions are-
explanatory and response variable if it's not a
Oh.
So be
I'm thinking
looking
it's
there.
Yeah.
So let me ask you this, did I show y'all the study about, or the information about the study of,
So A is.
cell phones and mental health crises?
Yeah, you told us about that.
Okay, so
Can I read it?
in that, that's an observational study, we just looked at mental health crises, right? It's retroactively looked at the data after the fact. And we weren't able to establish cause and effects, but was there an explanatory variable for the rise in mental health crises?
Green leafy vegetables.
Phones, right? So you can still have the variables, you just can't necessarily say cause and effect, you can only say there's
Alright,
Or like
so
the
do you guys think it's an experiment or observation?
correlation.
So,
So
basically.
you might wanna.
Oh, sorry.
I said in the
Well, you can still get it. Well, okay, so on your D, yeah.
So just, hey, just look on with it.
You okay?
So, what have we got so far?
I'm just like.
Observational study or
I'm
experiment?
gonna peek out today.
Oh, really? Why?
So why is it observational?
Oh, just stress.
So when you say they didn't do anything, they didn't apply what? Treatment. So we gotta study that vocabulary, right? They didn't apply treatment, they just observed people do their natural thing. They did
Well,
not
what was
interfere,
that
right?
cartoon about then?
So we move on to, let's talk about B and C, focus
Oh,
on
and like
B and C.
osmosis.
I got you on it. What do we think of B and C?
I don't know.
And beavers. Yeah.
It was like.
How does water affect metabolic rates?
Wait, I don't like your food. Okay, you do. I'll do. Based on the study, is it reasonable to food that eating fruit
Not exactly.
Yeah, it's as much as coffee, that's like genetics.
up
So let me
and
just
If
ask
it's
you
not
something. When
fictional,
you
say
see
it.
the word explanatory.
I have a question. Can you make B more specific
And
for
when you
your
say response,
explanatory?
it's responding to something, right?
Because are they
So,
talking about diet?
Look for your variables. Maybe start with just what are the
It's
variables,
not exactly the entire.
and then
text.
figure out which one is
So
explaining.
So what class do you
Which
have?
one's
Right,
responding to the other.
It's really important when it comes to like
Correct.
Yeah.
We should think very
Not
heavily
to,
about
or no, everyone needs to, I not
So what are the
to
variables
you need to
playing?
be specific. So like that is partially correct. It has to be
Yeah. So how much?
But they're not-
that is
they're
in
all
diet.
changing a specific diet, right? Like you wanna be specific about what the variable is.
So the amount of.
I was saying, isn't all about A and B? Okay, so
Really
but my
talks
question
about
is,
we
what
all
are the
just put
variables?
in our.
The variables
So
are
we can focus on. Like how does she?
green leafy vegetables that are high in these things, and what is responding to that
Oh yeah,
diet,
guys.
A and B.
Like.
What's your explanatory? So those are variables. What's your explanatory? No, that's the danger when that's the problem.
Yeah, specifically, because you can have
I think I got
Explanatory that we talk
that
about.
aren't high
Are
in
there other things?
whatever those are.
That's
for everyone.
How often people get A and B?
Alright,
Okay, so what else besides the diet could explain? Genetics, right? That would be a
can
confounding.
we be more specific about our
Does that
explanatory
help this start to
variable?
make sense? Other health, just like weight, age, gender even, right? Like, so be careful, it's not that they don't matter, it's just not the things we're interested in. They affect the response, they're related to the other explanatory, but we're not interested in.
So we're only worried about like.
Or what you designed to come up with, like what study you were looking at.
So, I mean, I think, no.
Are you saying the intake
It's like
of,
correlation, not
Yes.
What? Correlation, not causation?
So the only thing that they do that you guys really should take.
So, I mean, 'cause you can't say
into
confounding,
account
because that's not
for
Just because
It's not as much wording.
Well, so actually, and so don't let me forget to talk about this, the whole issue is that there is
like
confounding,
they were
which is
usually
why we
put
actually cannot establish cause and effect.
I see.
right, and
So,
then they went
if we
to-
do not account
eating
for
greens. But what
the
if
issue
it says
of
about these
confounding,
greens?
then we
that
don't
we're
know
talking about?
if it's actually
So I
the
would
actually,
put
like,
it,
give them-
green
I mean, I
leafy
guess
vegetables
for
that is
example,
causing the
writing
lower
it,
risk.
I put
We
that
know there's a
on
correlation,
high
but there's
end.
other
Yeah.
variables at play.
No,
So
it's
can you
fine.
talk about
I'm just
your
making
answer?
sure like
Yeah.
you guys know to be specific, because that's
We
what
can
they
talk about
don't
confounding variables.
I think both of us.
So like right here, based on, is it reasonable to conclude? Yeah, no, that's what you should talk about, is like, no, we
That's
cannot.
fine.
We cannot establish cause and effect because, confounding was not accounted for. You could also just talk about the fact that it's not an experiment, right? Like, there's no treatments to account for confounding variables. Alright, so,
That was
y'all had the conversations, we've had the discussions. So I want to give y'all a chance, let's talk about it quickly and then write it down in our notes, whatever we need to. First off, everyone agreed it's observational because there were no what? Treatments, guys. If there are no treatments applied, it's not an experiment, it's got to be observational. So no treatments, it is an observational study, okay? But were there still explanatory and response variables?
Yes.
Yes, and so it's important to recognize, and the Kings are having this conversation, even though it's not an experiment, you can have explanatory and response variables. First, identify your variables. That's one thing, right? So we have whether or not they develop the eye condition called AMD. That's one variable. And then the other variable is how many leafy lean vegetables they ate. Notice I haven't said explanatory or response yet. I've just identified the variables. Now I take the time to think, okay, which one's explaining the other? Okay, green leafy vegetables is explaining the response of risk of AMD. So my green leafy vegetables is explaining my response of lower risk of AMD. So it's just quick notation. Does that make sense though, how I annotated that?
Yes, sir.
Okay? And so because it was an observational study, not an experiment, is it reasonable to conclude that eating green leafy vegetables causes a reduction in the risk of AMD?
Yes.
No.
What do we have to have in order to establish cause and effect?
Treatment.
You've got to have treatments, you've got to have an experiment, and specifically that reduces what again?
Confounding variables.
Right, we have, when it's an observational study, we have nothing to reduce confounding variables. And this is what I talked heavily with the fours about. So let's start with this statement. No, it is not reasonable. It's not reasonable because no treatments were applied. And no attempt to reduce confounding. So there's no attempt to reduce that confounding. And so people were asking about explanatory versus response, about what confounding is. So I talked about this. What are some potentially confounding variables? What are some other variables that could explain the risk of AMD?
Genetics.
So, essentially confounding, sorry, let me finish writing this. Please do note, I put this word potentially there. I'm very intentional about that. Do we know that genetics are confounding? No, it's just potentially, right? So, potentially confounding variable, yeah, one of those would be genetics.
Gender.
Gender is a potentially confounding variable. What's another one?
Environment.
Drug use.
Ooh, environment. Drug use. See, these are some things I wasn't even thinking about. Environment, lifestyle, drug use.
Screen time.
Okay, now we're getting too specific.
So, but this is kind of the point. Like, there's all these things that could affect an eye condition, right? All of these things can affect AMD, age-related macular degeneration. And so, if we don't account for those variables, can I make a good inference about how the diet is affecting AMD? So that's the whole idea. When there are variables that are related to the explanatory and response, but they're not accounted for, that confounds our results. It messes up our understanding of cause and effect. And I do like, and I heard other groups talking about this, but I do like this idea of noting, hey, there is a correlation. However, I will cause this.
Correlation.
Well, I wasn't talking about that.
Whatever.
However, I just want to point
This is
this out.
not an English class.
Have we proven that there's no causation?
No.
No, we just haven't proven there is.
Well, observational studies.
I know, but it's important to say that we know there is correlation, but we haven't proven causation. Because there still could be causation there, we just haven't proved it yet.
Could you say
Okay.
causation is not conformed?
What?
Correlation is not confirmed.
Confirmed. Got you. Yes, it is not confirmed.
Thank you guys.
Yep. I was like, conformed or not? Yeah, okay. Does this help us understand explanatory response and confounding a little bit better?
Yep.
Is that, Sanaya, Lana, y'all more comfy with that? Because I think y'all are the ones asking.
Yeah.
Right? Okay. All right. All right. Really quickly, I do want to point out, because I was looking at the, I think it was the proficiency scale or something else. Do you have your proficiency scale right in front of you? No, that's right.
Do we turn those in at the first
That's
test?
still the longest time was.
Because I've been like checking them, so.
It's like if you feel like you, well, this is, so the proficiency scales are a self-assessment for you to prepare for assessments. So like I told you before the quiz what concepts would be on the quiz, right? It was all about the bias, it was about sampling, stuff like that. And then I also have a copy that I will be marking off for you when I see proficiency with concepts so that you have chances to show me proficiency later. No, I'm not seeing it. So there's a difference between the elements of a study design and components. That's what I was going to talk about. So really quickly, I just want to point out that you're going to hear two different terms, and then after this we'll go to the DYU. There's going to be the elements of study design. The elements refer to things like your explanatory variable, your response variable. Your elements refer to your treatments, your experimental units, your factors, your levels. Those are the elements of the experimental design. Then there are the components, which are some other things that I'll show you soon. So I just want to be clear on that language, because I think they have it in the book or they have it in the notes from Skew the Script, something like that. That's all, and I was like, I need to clarify. So your elements are the treatments, the factors, the experimental units, the level, the explanatory and response variables, confounding variables. Those are elements of the study. Okay? And then before we get to the components, we're going to look at the DYU. Okay? So, looking at this DYU, so I'm going to actually project this. Can y'all see that a little bit? Alright, so here's those first set of instructions. So first off, be careful. This is how I will do, instead of doing true, false, I will always do it as, hey, here are false statements, tell me how to correct them. And so one thing I do want to point out is, we need to be efficient with our time. So you don't have to write out full sentences here. But I do want you to show complete understanding. So, yes?
Can we write on the test?
Yeah, I've already made scans of them. Those are yours to make whatever notes you want to. So every time I ever give an assessment, I will give it back almost as soon as possible. And it is yours. Unless I say don't write on it, it is yours. You will hold on to it for the rest of eternity. Like until you die. Don't you dare lose it, right?
I'm gonna burn it on a bonfire.
I'll fight you.
We can do a
Show up and
Julia
I'll
did,
put your
remember?
bonfire out.
It'll be in my casket.
Oh, okay, there we go. That's what I like to hear. Okay, so I just want to point out, for some of these, some of us corrected, like half of it were noted, like one word to change, something like that. I want to see as complete of understanding as possible. So sometimes, maybe you did perfectly change it, but for like one detail, but I wanted to see another. For instance, number one, when we say clusters, what's something that should immediately jump to our brain?
Heterogeneous.
Heterogeneous, right? Those heterogeneous groups. And so, notice I made the note of clusters are heterogeneous, underlying the homogeneous over there. But I also clarified what is homogeneous. What's the group that's homogeneous? Those are
The same.
strata, right? You see how I addressed both parts of it? Yes.
Can you make it a little bit, like the roof a little bit darker, because I can't really see.
Can you hit the lights? See if that helps. Okay, so once again though, it's just that idea of really adding as much information as possible. So it's adding those details in. All right. Number two, what's it called when we don't actually obtain information from all individuals? Non-response, right? And I guess I didn't make it super clear, but I did do a 3-word. Notice I was efficient with my words. Quick response bias, what? That is when we, what does it say right here? Can affect responses, right? So it's not a complete thing, but I do want us to see and understand this idea that I'm trying to address both things quickly and efficiently. Non-response, they're selected, but they don't respond. That's what number 2 is. Response bias is when something in the design affects responses, which we'll see an example of later. Yes?
Wait, so why did I get? Oh, never mind. Never mind.
Cool. And then so for some of these, there was no way to like take multiple pieces. Like with number 3, stratified sampling is a sampling method that in no way involves simple random sampling. Well, the reality is that you have to do simple random sampling from within each stratum. And I think Peter, maybe I remember almost doing this perfectly where he, or somebody said it was like, then you put all those samples together to get your complete sample. Like that was 100%, 1000% correct, right? You do a simple random sample from within each stratum and then put all those samples together. You didn't have to go to that level to get an E there, but you did need to note, hey, no, we do simple random samples from within each stratum. What's up?
Wait, so what, how did I get that one wrong?
What
I
did
did
you
yours.
say?
Let me see it.
I said stratified, I just crossed it out.
You
Stratified,
didn't, you got an E.
no, on 3.
So, looking at the rest of these, what questions do you have while they figure that out? What questions do you have about these left up here? Number 4? Oh, number 4 is the one I need to talk about for sure. Any others besides number 4?
Does that make sense? Like you just scribbled it out. so you
Yeah,
can
I think
live.
that's the one I need.
How about 5?
So that's why
Talk about-
it's
what about
hard.
number
You didn't get it
5?
wrong.
I mean, I just got.
You got it right.
What'd you say? What'd you put?
I changed sample to census, but yeah.
Ah, so remember, the study that collects data from the entire population is called a census. But what's all of the individuals? That's just the population. So you gave the study type for the population, but the entire collection of individuals or objects about which information is desired is called a population. What's a sample?
Sample is a portion of population.
Yeah, subset.
Okay.
Yeah,
I think I only
Okay.
used one.
yeah. So,
One,
any
no, I
other
got
questions
partial
before I
credit
talk
for
about
this.
number 4?
I got partial credit.
Well, actually, after that,
Yeah.
this is number 6.
Okay.
Partial.
Yeah, so you crossed out, okay.
Yeah. maybe.
So I will say this, I think I'm gonna make what this is out of a little bit less because there's a little bit of confusing wording with number 6, which is part of the reason why I also didn't tell y'all what it's out of, because I'm still a little not sure. I might lower what from what it was planned to be. But we haven't talked about the the phrasing inferential statistics yet,
Oh,
but
yeah,
what does
was
that word inferential make you think of?
Inference.
Inference, right, infer. So there is a whole section of statistics called inferential statistics where we're gonna take a sample and learn how to learn how to make a statistical inference about the population. Okay, this sample mean is this, so I believe the population mean is this, okay? But that's what we mean by inferential statistics. But the inference with experiments is cause and effect. The whole point of inferences with sample surveys or observational studies is to generalize from a sample to a population, right? So the inferential statistics was a distractor, I think, for a few of us, which is why I'm going to change that. But number 4, this is where I need you to keep in mind or pay attention. Like right here, I need y'all to look at this. Okay, this is that house of gold thing, right? If I continued to collect more data points with this top one, where you got to pick which 5 words, would that have fixed my bias?
No.
A higher sample size does not reduce bias. Your eyes were drawn to larger words no matter what. Okay? So a lot of us on number 4 crossed out that word eliminate and put reduce, right? Which, can you ever eliminate bias? No. You can only reduce bias. That wasn't the real problem in number 4. The real problem in number 4 is the idea of increasing sample size. Guys, if my sampling method is bad and I collect more data, you know what I still have? Bad data. I have bad statistics, right? Okay? So if I collect more data with a bad method, I still get bad data. Increasing the sample size just reduces the spread of the data. So for example, how many words did we select here in this random sample? How many words?
Oh,
We did 5, guys. We did 5 for every single one of these. So we did 5, right? And you see how spread out this data was? If I chose 10 words instead of 5 words, the data might look something like this. It would have had the same exact mean because it's not biased, but by increasing the sample size, my spread decreases. So please make a note of that to yourself right here. So 1, sample size does not affect bias. Bad sampling is bad sampling. Sample size does not affect bias. Okay? Increasing sample size reduces the spread, but not related to bias. If it's consistently missing the mark, it's still going to consistently miss the mark, even with more data in there.
Reduce the what?
It'll reduce the spread, right? So remember, it was this spread out here. That's my range, however long this is. But if I increase my sample size to 10 or 20, it would have been narrower, less spread if I had a higher sample size. So it does not reduce bias. Bias is about bad design. Increased sample size reduces spread. All right, questions?
Nada.
We good? Okay. One note I will make, I think everyone got number 7 right. Does anyone, I don't think I needed to talk about that one. If I need to, let me know. Just a quick note on number 8 is this. Okay? A large simple random sample of people aged 19 to 30 living in the state of Colorado was surveyed. So guys, if I'm surveying people in Colorado, does that tell me about everybody in the US?
No.
If I only talk to 19 to 30-year-olds in Colorado, does that tell me about 50-year-olds in Colorado? No. What's the only population that I can make a prediction about? 19 to 30-year-olds in
the state of
Colorado. I only collected data from 19 to 30-year-olds in Colorado. I can only predict about 19 to 30-year-olds in Colorado.
Wait, then what's wrong with A?
Who were in the survey. If they're in the survey, then I don't need to make an inference about them at all, right? It says, to which of the following populations? If they were in the survey, they're not my population, they're my what?
Sample.
Right. Yeah, does that make sense?
Yeah, okay, I get it now.
Okay, so, and I will say this is an old AP question, right? Like, this is an old AP level multiple choice. And this is where you have to learn how to start breaking this down and say, okay, these are super similar. What is the difference? Oh, in the survey versus not. Well, wait, if they're in the survey, they're the sample. But I'm trying to make a prediction about all, right? Lana, did I see your hand start to go up?
No.
Oh,
No, sir, sorry.
oh. I'm just seeing things? Or you figured it out?
I'm trying to figure it
Well, if you ask your question, I can help you figure it out quicker.
out. No.
Okay. Don't make me sound like that, like, hot dang. Okay, I think the only one in 9 through 12 that gave us any trouble was number 12, maybe?
Yeah.
Yeah. So remember, even though it says the word number, that does not make it a category. One thing I will point out, I realized this while teaching with my Algebra 2 students. What's the core of categorical? It is a category. What is the core idea of quantitative? It is a quantity. Is a phone number a quantity?
No.
No.
You can count it up, but like, it's,
But you're not counting to get the cell phone number, right? It's a category. It's no count, no measure. Categorical. Right. It's a category. Okay? Alright. Number 13. What questions do you have about number 13?
C.
C?
How do you know what that's what it is?
Okay. What were y'all thinking C was?
I picked selection bias. I did too.
So,
I completely had no idea about convenience, but that word did not cross my mind.
and it's more convenient sampling, it's closer to undercoverage. So, the idea of, you said selection? You say selection or sampling?
Oh, that's really
Selection bias? So, selection bias is heavily related to undercoverage. What did we score that at? Well, you didn't say selection bias, you said selective bias. Wait, you said selective response. Yeah. That selective response is not a thing, okay? Selection bias or undercoverage. The bigger issue is here where he said he chose people. He didn't, he took the first 50.
To get ready.
He's kind of choosing, but it's not choosing.
Kind of sampling is.
Yeah, okay.
Score this too.
Just pull words out.
Any other questions about number 13 that I can answer? So I tried to give feedback, we tried to give feedback, ask questions on there. Here are the responses. What are your questions about number 13?
So even though that was just wrong, what
Yeah.
about like this, like the extra info?
Well, and that's the debate and discussion we had, was like, you had the right idea, but not the right term. And like, if you had been closer with just selective bias, that'd been okay, but selective response bias, that's just too far away to get it, yeah. Okay. Any questions before we continue? Okay.
Oh yeah, I
Now,
like that.
Number 14 is one I'm going to heavily address, and I need y'all to pay attention to, because this is critical to understanding statistics and being successful on the AP exam. So first off, statistics and parameters, it's up there, right? Serena, we'll talk more about it in a second. But what does the term bias mean? First things first, if there is bias, that means repeated sampling will result in inaccurate data. That means our data or our samples are going to consistently be non-representative, right? Samples consistently miss the mark, right? Or non-representative. You can say anything along these lines, but we have to make sure that we understand that if it is biased, our sampling is non-representatives. Not just one sample misses the mark, but consistently our samples miss the mark. They are non-representative. So that's what bias is. You've got to have that down. And so why is bias an issue when collecting data? This is a big thing for a lot of us on our Frere models, and one of the reasons why a lot of us miss this here. What's the entire goal of an observational study? To make what kind of inference? About the population from a sample, right? Our whole goal in an observational study is to take a sample and make a prediction about the population, right? Well, if my sample doesn't look like the population, what's my problem?
You have BS?
I have BS, I have bad statistics. I cannot make an accurate prediction about the population. Like, if I have bias, if my samples don't look like the population, then I don't make a good prediction. That is wicked important to understand, right? That if my samples don't look like the population, if my samples are consistently non-representative, I'm not going to have accurate predictions. A lot of bias completely prevents me from doing the entire goal of an observational study. Yes?
Wait, so I'm talking about 5A, right?
We're talking about number 4 right now.
No, I meant like,
Yeah.
I'm asking about 5A.
Oh, well then hold on to that.
Okay.
Last detail or note, what do you have to have in observational studies to reduce the effects of bias?
Randomization.
Randomization, some kind of random sampling. Yes, ma'am?
Can I mention something
Yeah.
I saw? So I saw, on the ones I looked at, a couple of them, every question wasn't answered, right? So when you read through it, like, you think you might have answered it already. So when you do questions like this that are like, there are 3 different questions within this one question, make sure you're answering them, because that was an issue a couple times of, I guess you just forgot to write it down or skipped over it, but make sure that that's something you're doing for the future.
Alright. Yeah, 5A. Michael?
Yeah, so about like volunteer response, right?
Yeah.
I thought that was like a response, like, how do I describe this? Like,
bias?
yeah, like a bias, not like a sampling method.
Volunteer responses is a sampling method, and those sampling methods are almost always biased. It's both.
Okay, wait,
Sorry that was unclear, but we'll
Yeah.
learn that before the
This
test.
is a question.
okay, cause I,
Yeah. So I'll continue answering in a second.
I heard that wrong, and
Yeah.
it still says essentially correct.
Yeah, so I'll talk about that in a second, don't let me forget. So again, the idea is like volunteer response sampling, like the sampling method. I put my survey out into the ether and I let people respond if they want to respond. That's volunteer response. That volunteer response sampling is biased. It is both and. Sanaya.
At the top,
Yeah.
it was like repeated sampling result in inaccurate data. What was biased? It was like curves, I couldn't see. It's above that.
The thing that you had circled in a weird.
Yeah.
Non-representative?
Okay, thank you.
Yep. Okay. Okay, so what Braden was asking about is he actually missed part A and still got a what again?
So essentially correct.
Essentially correct. One of the things that the AP exam in statistics has started doing over the last few years is if there's something that has 4, maybe 5 pieces to it and you miss just one of those 4 or 5, they'll still let you have essentially correct, because literally it is essentially correct. It doesn't say it has to be perfect. That's one thing I love about AP Stats. If there's lots of pieces like that, you can get essentially correct. If there's only 3 parts to it and you miss one of them, it's going to be partially correct.
And it's not this.
4 is where it starts to move to maybe still be essentially correct.
I assume that's up to like the grader's discretion.
Yeah, sometimes. But there's still limits, like there's requirements on it. Yeah,
I had a
Limits.
question.
what's up, Nate?
Oh, on, what was it, D?
Yeah,
So grouping, it has to be more than one, right? A group just can't be an individual thing. in
on
itself.
5D?
On a D, on SRS.
Yeah. Simple random sample, not stratified. When we say SRS, we mean simple random sample, right? So there's no grouping involved here. She puts all her students' names in a hat, she mixes them up and selects 3 names from the hat. You'll see, by the way, some AP Stats teachers teach this method. It's goofy. We live in a digital age. I'm going to use technology or something that's better than just throwing names into a hat. So that's an option. But she mixes it up, selects 3 names, and they're good to go. Does that explain why it's SRS though?
Mhm.
Is that what you're asking?
Yeah.
Okay. Lana and then Peter.
Can you talk about C?
C, yeah. So literally think about that word systematic as in there's a system. So we select the third senator, and then we have a system of every seventh senator after that, right? So if we randomly select one senator or one individual and then pick every fifth after it, or we do every 10th after that, that's a system, a systematic random sample. The first individual was randomly selected, so there's still randomness involved in the rest. Does that explain that detail? Peter?
On A, I put like, instead of putting response, I put sampling. Would that count, like that part just wrong? Or-
Like you did volunteer sampling?
Yeah.
Nah, I mean, like, I would put volunteer response sampling
Yeah.
is the full thing I would put, but no, I mean, it's volunteer
Like they
sampling.
know what I'm saying, and like I accept credit.
Yeah.
They're so extra.
And again, guys, by the way, I just want to always remind y'all, because I know for some of us, we're sitting there going, what the frick have I got myself into? Listen, it's always a new experience jumping into a new class. Don't sweat it. You got to learn how to get better at it and develop and grow. But I'll get you there, I promise. You had to have the first assessment at some point, though. All right, so this one we talked about a little bit yesterday. The biggest issue that I saw, and I think Ms. Kowalski also saw this in part B. So again, it was volunteer response sampling. We talked about this heavily, right? She pushed this out to her followers and let them respond. That's volunteer response sampling. It's one of the bad ones. And so explain how it might lead to bias. I think maybe it was Sprig. Did I make a note on yours about, hey, don't let me forget to talk about this on your 16A? Did you make a note about, who made a note about the 24 hours?
Oh, that was me.
You did,
Oh, I also did that.
and you also did. One of you I made a note of.
Whole population is only whole followers though, comma, so is that a problem? Question mark.
Yeah, there's a,
Same as 15A, I don't know.
yeah, that was a volunteer response. I don't know, maybe I'm losing my mind. But,
Were you the pig pen?
yes.
This is importance. I don't know if that means anything.
You put discuss for B, but not A.
Oh, what did I put for, about discuss for B then? I know it's,
You just said, gotta discuss, which is kind of snarky. Just put, Oh my goodness.
But,
yeah, we got discuss.
Verbatim.
I mean, I am snarky, but. Okay, I don't remember what I was saying about that. I don't know. Alright, let's talk about this though. Listen, okay?
He's so rude.
So, right here, okay? How might this lead to bias? So be careful, we talked about this yesterday. The only people she's trying to make an inference to are her what?
Followers.
She's only making an inference to her followers. So the fact that she puts it on her social media is not a problem, okay? The question being on, well, and I think some of the people who said it really well of, look, the people who like her the most are the ones who are going to respond. If you follow her but she's kind of meh, are you going to respond to this and be like, oh, I hate you, no, you're not my favorite?
No, you should never say anything.
Maybe.
Yeah. Some people, because Michael's a troll, but for a lot of us, like, we're just gonna chill. That's what really we should have been thinking about is, okay, you're only really gonna respond if you're like, I love you and I want the absolute best for you and I want to just jack up your numbers, right? Like that's what people are gonna respond. So that's the bias that would be happening here. I did think about it later, and this is why I talked about, or I thought I noted the 24 hours for some people. Are there some people who follow someone and like them, but don't necessarily see it within the first 24 hours?
Me.
Yes, right? Like that does happen. So there could be bias because of that, because there's followers who do really like her and could have responded, but didn't get the chance to because they didn't see it within 24 hours. So I didn't originally think about it that way, but notice you have to add that little bit more, not just say, oh, the survey disappears in 24 hours. Now, for the next part for B, a lot of us said lower, and I think you meant the right thing, but misread the question. Because be careful. The way it read, some of y'all, it sounded like, and tell me if you saw it differently, but I saw it this way where it felt like y'all were saying you think that the true proportion of followers who say she is their favorite is lower, which is correct. The true proportion of her followers who say that she's their favorite is lower, but that's not what the question asks. The question says, do you think the estimate we found is higher or lower? So if this is our estimate, and here's the true value for the population, the estimate is what? A higher one. Be careful on the wording. And this is again where your explanation is important, because that could be the difference between a P and an I if you miss the right term there. But it was definitely higher than the true percent, right? These are the people we said thought they liked it more. But I will say this, and what I love about the AP exam, if you did the wrong type of bias up here and saw it the wrong way up here, you can still get an E here if you build this answer off of this one. So make sure you're constantly thinking about what you said in the past and building on it, okay? Does that make sense though, why it's higher, not lower?
Yeah.
Okay. Any questions through number 16?
What about the grading part? Like, there's a check mark and there's. What is the check mark for?
Well, the check mark is to say, yes, you got it right, it was higher, but your reasoning was wrong, which is why you got a P. Yeah. Okay, so again, that's how that can sometimes work. Okay, and I'll show you more about the EPI system with the actual, when we start doing free response questions. Woo, y'all made me mad on 17A here. I told you, what's the 3-step process? When I ask you to describe a process for selecting a sample, label, randomly generate, and select. Guys, not every guys, but like for quite a few of us, too many of us guys, when it's asking you to describe that process, label, randomly generate, randomize, and select. Okay, so be careful with it. And remember, we're selecting 360 unique numbers, but we got to select the students. But we had to label all students, right? We label one thing, and I don't remember if it was multiple people or not, but you said there was someone who said randomly generate, right? Be aware on the AP exam, it is not enough to say randomly select. You have to refer to a random number generator, a random digit table. You can use the hat method that we saw earlier, but you have to be clear that you're using a random process, because just the word random is not precise enough on the AP exam, which is fair, because how often do you hear people go, oh, that's so random, and it's not random, it's just a coincidence, right? In the normal English language, we use random way too often when it's not truly random. Okay? Questions? Yes, Lana?
Why do they do 360 to be like a certain percent of the...
I thought they told us 360.
Yeah.
Yeah, if you look at method 1,
You're right.
they just told us 360.
You're right.
Yes, that's right.
If I had said label all students, all 3,600 students, would I have gotten full credit?
See, and so even that would not be quite enough, and so that's a good question to ask and learn from this. The reason why you cannot say label all 3,600 students is because you're not, and it's dumb. I agree, I know that the implication is there, but they will make the argument that you have not made it clear enough that you're not repeating numbers. You have to, well, think about it this way, and I forgot to bring this up when I talked about it before, but on the actual AP exam, the way they described it is, you need to make it so clear that you can stick the instructions into a computer and it perfectly does it. Your computers cannot read your intent, they can only literally do what you tell them to do.
So you have to say unique?
So, well, we have to randomly generate 360 unique numbers. But by saying we're labeling all students 1, 2, 3,600, that is clear enough that it's going 1, 2, 3, 4, 5, 6, etc.
Wait.
What Serena was saying was label all 3,600 students. If you don't say 1, 2, 3,600, that's not clear enough for the AP exam.
That isn't dash.
That's the same thing, 1 to 3,600.
Say that again?
you have to make it clear that you are labeling them from 1 to 3600. You can't just say label all 3600. You could do 1-3600 or 1 to 3600. Okay?
I said third. Is that valid?
Say again.
I said third. Is that valid? 1/3.
Yeah, yes. Did you get any? Did we make a note on it?
Huh?
No, okay, good. B and C, do we understand why B is stratified and why C is cluster? And those benefits there. Okay. What, Brayden? Why are you giving me that look?
Change your answer, or change like how you're grading something better. I'm wondering like, would you ever change a part?
Oh, no, I messed up. Yeah, no, I just messed up. I misread things. It happens, I made mistakes. Okay, so last couple of things, and this is what I need us to hear. One, if you want a copy of these solutions at the end of class, let me know and I'll print a copy for you. Two, I need you to remember that learning takes time. It's okay if we didn't get everything perfect this time. I know I got a few precocious juniors in here who are tweaking out because they're like, I don't know what less than 100 is. Well, you need to get over that, okay? That's not healthy. Trust me, from experience, Peter, that's not healthy, okay?
Well, I'm not gonna deny it, like, so.
Okay.
Okay? But here's the thing, listen, I can tell you this legitimately, and listen, okay? I went to Lamp High School, for those of y'all that don't know, it's ridiculous.
You don't have to remind
This
us.
is the first time in the entire year. Listen to me actually talk about
We
this.
only 15 days into the year.
Hey, shh.
It's only 15 days into the year.
Academic year, whatever. My point is this. I was wicked stressed out when I was at Lamp. That's my point. When I learned in college to focus on learning and that learning process, I learned better, I earned higher grades, and my life was healthier. My mental life was healthier. It's okay to not get things perfect the first time around. Take that pressure off yourself. Focus on the learning experience. Okay?
But what number will give
So if you want a copy of this after class, let me know. Coming back to AP Stats. So now we got to get into the components of experiments, right?
These do not. Like he might not be.
My academic anxiety didn't go away until after.
He's being mean. He's being really mean.
Oh my
I
gosh.
just want to know the results of the
Y'all should fight.
Children.
Huh? Oh, Jaden?
Do we need to talk with each other and help you make up after class?
What number gets you an A? That's my question.
Great question. I don't know yet.
Peter, how many points did you get?
Oh wait, I didn't.
All right.
Huh?
27.
So
27?
Wait, what?
What you
Oh my god!
What?
This is why you don't ask.
yeah, I wasn't gonna say
Yeah,
what the
don't
high
compare
score
yourself.
was. Like, why are you gonna?
We just went over this.
Yeah.
Just went over how bad it is.
How bad what is?
Comparing.
It's
Oh,
so
right
dumb.
though.
Yeah.
It's terrible.
It's so
The thief
dumb.
of joy.
Huh?
Did you see Mr.
Oh frick! Yeah. What time do you have to leave? 3?
Like 3?
Okay.
My
Yeah. that's
God.
fine.
What time
It's so over.
2:40. All right, so we got to cover some stuff. Okay, so components of experiments. So remember, we talked about the elements of experiments, right? Your explanatory variable, your factor, your all those other things. Now we are talking about the components of an experiment. What are the things we got to do to help our experiments? Oh no, components are elements. I lied. Components are the same thing as elements. I don't know why I changed the language on myself. Components of experiments are the elements of experiments. Principles of experimental design is what I'm about to get to. Whoopsies. Experimental units. Individuals or subjects. Remember, in this context, this study that Serena's been freaking out about for the last day, we're looking at the science lab faculty. The explanatory variable, what is being manipulated, the treatment, was the applicant name, right? And that was explaining, so it's Jennifer or John, that was explaining the hireability rating and salary estimate. And we're trying to test, hey, is it actually gender discrimination that is affecting the gender gap, right, in STEM fields? And so we did this, or this experiment was done by Yale, I think I said. Does that sound right?
Yeah.
And so now we're getting into the principles of experimental design. So components are the same thing as elements of experiments. Principles are here though. When we talk about the principles of experimental design, these are the major ideas. You have to have at least how many treatments? Anybody know? You have to have at least 2 so that you can do what?
Like
compare. Huh?
Compare the results.
You gotta be able to compare the results. When it comes to experimental design, the first principle is that you have to have at least 2 treatments so that you can compare them. So did we have comparison?
Yeah.
We compared John and Jennifer, right? We have to have control of confounding variables. So when we looked at the 2 what am I looking for? Resumes, what were some other variables that could have affected the hireability of somebody? Their GPA, right? If John had a significantly higher GPA, you know who I'm going to hire? John. But what did they do? They kept the GPA the same. What's that called? Control. They directly controlled that confounding factor. Okay? When you know that there is a potentially confounding factor, control it. Keep it the same for everybody. Okay? What's another potentially confounding factor that could have gone into the hireability of somebody or your predicted experience, right? So what do we need to do with that experience? Keep it the same. Keeping it the same is called control. Okay? Anybody know anything else that could have affected the hireability? Jaden?
If the, what's it called, the people at the lab had past experiences with the people whose names are John or Jennifer?
Okay.
The resume format.
Like,
That's true. So like, what I think maybe, that's,
It's a stretch.
hold on to that. Because can you control that?
no.
So we're going to talk about something that we can do to reduce the effect of confounding. Because I will say he's right. Like, I can tell you this right here and right now. As a high school teacher, there are names I never would have named my son. Point blank period, okay?
Like Jaden?
Yeah, Jaden, for sure, 100%, right? Didn't know him at the time, but
What's
yeah,
your son's
never would have
name?
named Alex Jaden. And so there are just names I'm never going to name my son. And so people have different experiences. But can you control the experiences that people have had with John or Jennifer? No, so that's not a variable you can control. Okay?
The gender of the interviewer?
Now, okay, so of an interviewer. So I will say this, the gender of the interviewer may be confounding variable. But we aren't doing interviews, we're just doing resumes, right?
Yeah.
So is it possible that gender of the person receiving the resume affects things?
Yes.
So could I have directly controlled and kept everyone the same gender? We could have,
Try.
but it probably wouldn't have helped us get as accurate a data as we wanted. Yes, Serena.
Where they went to university.
Okay, so where they went to college. Different colleges have different amounts of prestige. Would you hire someone from MIT or from Alabama?
I don't know. Alabama has a pretty
Alabama's
good
pretty
engineering program.
I don't disagree, but you and I both know you're going with MIT. Okay, so listen. But again, right, you're right. The college they went to can affect things. So on the resume, we directly control that variable. If there is a variable you know could affect our understanding of gender discrimination and the gender gap, we directly control it. But can we control every variable?
No.
No. So Jaden, you said relationships with people named John or Jennifer, right? You can't control that. So what do?
Just hope it doesn't affect that much.
No, we can't hope.
Pray.
No. There's an R word.
Reduce.
We may want to reduce confounding, but how are we going to reduce that confounding?
You do it
Okay.
again and again.
You do it again and again. So one, it's
Recycle.
called replication in statistics. So one, like if there's one or two people and that one or two those one or two people had a bad relationship with a John or Jennifer in the past, that could affect your results, right? How likely is that to happen though if you have 60 for each?
Unlikely.
Not very likely that you're going to have 60 continuous issues. So one principle of experimental design is replication. Okay? So we have, what was the previous one? Comparison. We've got to compare. We've got direct control, right? They even controlled for likability of name. Jennifer and John were tested for likability of name. The big one that y'all are missing is random assignment. Now, I need y'all to pay attention. This is not random sampling. This is random assignment. What's the difference?
One is, well, random assignment
Some are
is
people,
very
some
true.
are I don't know.
We'll start with Jaden, we'll come up here. What?
Random assignment is for experiments.
Okay.
While random sample is for like observations or whatever.
So one, hold on to that truth. Random assignment is for experiments. Random sampling is for observational studies. Okay? So we randomly sample in observational studies. We randomly assign in experiments.
Does it have to, the fact that the treatment's slightly different? Like, it's like one person get a resume of John, one person get a resume of Jennifer?
So one, yeah, so here's the thing, to really test this out, I can't send John and Jennifer to the same person because they would realize it's the same resume, right?
Yeah.
Okay. But there's factors like, and notice you say that word factor legitimately as a factor, an explanatory variable of past relationships with John's and Jennifer's. Can I account for that? No. So to filter out the effect of that confounding variable, I randomly assign treatments. So I name this person, or I label this person 1, this person 2, this person 3, 4, 5, and 6. And let's do this. Does anybody have a calculator in front of them? All right. Generate 3 numbers 1 through 6. And so this is how we would do it on an experiment. Okay, so use a random number generator. If everybody wants to practice doing this, this wouldn't be a bad idea, right? So randomly generate random integer, minimum 1, maximum 6, and I need 3 integers.
Oh, do we have to seed it as well?
You don't need to seed it again. Now you're good.
You said
Where's
3,
this three?
like,
Yeah.
6, 6. Got you.
Okay, so could I do 6, 6, 1?
I can't.
No, I can't. So I need to keep doing it until I get 3 different ones. 4, 3, 5. So that means 4 goes to John, 3 goes to John, and 5. You said 4, 3, 5, right?
Yeah.
Okay. So 4, 3, 5 are going to go to John, are going to get John's resume, and 1, 2, and 6 are all going to get Jennifer's resume. That way, because notice I'm not sampling. I'm not taking these people from the population. I am taking the sample and assigning them to treatments. Okay? Let me say that one more time. With random assignment, I take the sample, or let's say researchers to be more precise. Researchers take the sample and randomly assign to treatments. We took our 6 researchers, we assigned 3 of them to John and 3 of them to Jennifer. There are multiple ways to do this, but the simplest is to randomly assign half of them to one treatment and the other half get the other treatment. Okay? So please note the way that I did that was I randomly assigned half to one treatment, half to the other. You can also do it in thirds. Randomly assign 1/3 to the first treatment, randomly assign the next third to the second treatment, and then the leftovers get the third treatment. That's still random assignment. And the idea is, because it's random, I am filtering out the confounding variables that I could not account for directly. So directly control everything you can. Randomly assign to filter out the rest. Directly control everything you can. Randomly assign to filter out the rest. So for example, in this one, the way they have it set up is, let's say that we have a tier 1 and tier 2 research institution. The tier indicates how prestigious that research institution is. The more prestigious, tier 1, typically are going to be harder on applicants. So let's say that John was exclusively sent to tier 1 research institutions, but Jennifer was sent to tier 2. Well, now I don't know, is it the gender or is it the tier of the institution, right? Well, yes.
Well, the study said all 127 were from Yale. They want us to Yale.
No, but the
science
research-
I thought the researchers were from Yale and they sent it out to other
Well, they sent it
research.
to other researchers within their science department.
But,
Wait, what?
what did they
I'll have to take a look.
I
I'll
thought
trust
it
That's
you.
what I remember from the thing. From
Okay.
the
if they send the
abstract or
same
whatever.
people, how they,
Regardless, this is a concept of random assignment, right? But now we have confounding. Not sure if it's gender or lab quality that causes hiring outcome differences. So what do we need to do? We've got 4 institutions that are tier 1, 4 that are tier 2, and we are going to assign half of tier 1 to John, half of tier 1 to, or tier 2 to John, and then the others go here.
This is OCD.
Sorry. Now notice tier 1 and tier 2 effects are filtered out. Because I've got some tier 1 and tier 2 here, got some tier 1 and tier 2 here. So random assignment filters out the effects that we cannot control for. Let me say that one more time. Random assignment filters out the effects that we cannot control for. Or the way that they say to skew the script is it tends to balance confounding factors.
Say it one more time.
Well, since it's in the notes, you can just write down the word balance.
Where?
Wait, so we're gonna have a quiz on experiments as well?
It's not, it's just not really a blank.
Is there not a blank?
No.
Like, I just wrote it like right next to the thing.
Oh, random assignment.
Yeah.
Well, so random assignment tends to, I say filter out confounding factors. Young Shaver says balance confounding factors.
What is your version of it? Tends to what?
Filter out confounding factors.
Do we know the results now?
No, we haven't finished going over the study design.
Wait,
Well,
Three
at the
already?
end of this day, no, we started it yesterday.
No, we
Oh,
started
did we start it
Friday.
yesterday?
No, but here's the thing.
Well, I wasn't here Friday.
You're talking.
You mean Monday?
You know,
wait, what
You're,
results?
you're talking.
All right.
Say it more time.
So, as a quick note, right? So this is directly on the sheet, page 3. Sampling, random sample reduces bias. Random assignment reduces confounding. We're going to practice with the differences in those two, but we need to be aware, random sampling reduces bias, random assignment reduces confounding. Okay?
So we're gonna have a quiz on the experiment side?
Yes,
when?
Friday.
This Friday?
This Friday.
Wait, okay.
I said in 2 days.
Yeah, we'll be finishing this, not today, but pretty quick tomorrow and doing practice with all this stuff.
I need a distinguishment between check
Yes.
and
So yes, you will want the experiments fair model done on Friday for that quiz. What I will note is I would probably be doing some of the check your understanding from the book. The the progress check will be due on Friday, but I would highly recommend you do it by tomorrow so that you can ask questions before the demonstrate your understanding as your study and review time.
When you say ask questions, how?
At the beginning, no, at the beginning of class, write your question on the vertical surface. Yeah.
Is AP Bio that bad? I don't think so.
You just stay one? Yep.
It's so bad.
Okay, if you think about it, let me know. Alright, so, the other thing though, right, is you could, even with random assignment, if this homeboy has a problem with Jennifer and gets assigned Jennifer's resume, right, then he could rate Jennifer really poorly. So, would it be good to only do this treatment twice?
No.
No. And so when you do multiple, you call it replication, right? So if you replicate, you are going to do it lots of times, and the more times you do it, the better data you get.
Wait, so why does he have beef with Jennifer?
Maybe he has beef with John, I don't know.
No, but like,
Jennifer's
what's the
his ex.
beef?
Maybe Jennifer reminds him of his ex-girlfriend,
Jennifer dumped him.
right?
Dang.
He got dumped by Jennifer less than a week ago, and now he's got to hire this chick? That's a hard pass.
Dang.
Because he
Not even the same person, just the same first name. Oh no.
brought back memories.
Okay?
Lifestyle.
So, here's the thing. It's hard to tell if the differences are due to explanatory variable gender or just differences between the two faculty, right? So it is quite possible
Actually, that knocked over the camera.
that it is just, hey, one faculty member is way tougher than the other, right? So we don't know, it may not even be the name Jennifer. It could just be, hey, Mr. Kenny is wicked tough when he's rating these people to get hired here, whereas Miss Williams is really nice to them because she's way nicer than I am, right?
Oh.
So, like, do you see what I'm saying? Like, it could just be a difference in those people. So, we don't want to just do one time. We want to replicate. We want to see it lots of times. Yes, Jaden.
I was curious, what if there's a diversity quota?
Huh?
What if there's a diversity quota they have to hit?
Oh, that's a good question as well. There wouldn't be the gender gap that there is if there was a diversity quota.
Why are
That's
you
all I'm
adding
saying.
PEI, bro?
Okay.
Physical books.
Yes.
Making the
So-
books. When do the annual was again?
Fantastic question. I'll ask Mr. Hinton this first thing tomorrow because I have not heard from him.
What are we getting? Oh yeah,
What?
what are we getting this was?
Okay.
I'm looking at the PDF.
So replication 127, more replication, more data. Okay. So this I will also point out, and I want y'all to notice this. Larger treatment group size reduces the likelihood of differences arising due to chance alone. Notice this makes things more precise. Just like we talked about over here, if we have a larger sample size, what does that do? It reduces my spread. It makes things more precise. The increased sample size reduces that variability. It makes things more precise. Sonny, do we need to make sure you're in the front of the room so you can see moving forward?
Oh, cause you move on quick, that's why I take it.
Oh, okay.
No shade.
All the shade apparently.
Yeah.
Alright. So, replication. We get to be more precise when we have a higher sample size. That's important. Replicate the poopy out of things. So, I'm going to pause for a second. I just want to point this out. Principles of experimental design. What are the 4 things that you need to think about to reduce the effects of confounding variables? What are those principles?
Sample size.
Okay, so with experiments, when we say sample size, so I'll come back in a second. When we say sample size, there's an R word that we use for that. Replication, right? We also need that in a second, but we need to remember we replicate to reduce the effects of confounding. We need to what?
Compare.
We need to compare our treatments. There we go. We need to compare our treatments.
Random assignment.
We need to randomly assign to filter out the effects of confounding.
Control.
And then we got to directly control. Remember, start with comparing 2 treatments. Start with directly controlling every confounding variable you can think of. Then replicate and randomly assign to filter out the things you couldn't control or didn't think of. Okay? All right. Any guesses what we mean by completely randomized design before Serena loses her mind? And it's 3 o'clock if you... Who was it had to leave? Brayden?
No.
Who was it?
Me?
Jaden, and was it just you?
Yeah.
Okay. Bye.
I don't know.
Oh shucks, it could have been
Oh, it's
like
gonna be
1/3.
terrible.
Yeah. All right. So, completely randomized design, experimental design in which experimental units are assigned to treatments. Completely random. What do we always want to make sure we have?
Random.
Randomness, right? We need random assignment. So, if you hear that term, completely randomized design, we are going to, what with our treatments? We're going to assign them at
Random.
random. Thank you. Okay, guys. Completely randomized design.
I got thrown off there.
Experimental units are assigned at
Random.
completely random. Woo, there we go. So, good with that?
Yeah.
It is what it is. Don't make that one harder than it is. Okay. So, I like this language that Young Shaver uses. He says this is the SRS of experiments. Completely randomized design. And a completely randomized design is good, but just like with the simple random sample, we're going to study something called blocking tomorrow that is similar to stratifying. And remember how stratifying reduced our variability when it was done well? Blocking will reduce our variability when done well to find those differences easier, okay? But completely randomized design, this is the SRS of experiments. When I say SRS, I mean
Simple random sample.
simple random samples,
That's alright.
okay? This is the basics. You gotta have at least this. You can get fancier afterwards, but you gotta at least have completely randomized design. We're almost there, Serena. We'll get there by the end of the day, I promise. Don't lose it.
You got 14 minutes.
She might be tweaking out. Alright, so how would you implement a completely randomized design of the Jennifer John experiment with 127 science faculty members? What would you do? What's the first thing you would do for that? How would you describe it?
Make 127 resumes and
Uh,
try and split it evenly, so like 63.
Assign numbers.
So let's back up for a second. Let's think about this. We're just dealing with Jennifer and John, right? So do we need 160 or 127 resumes?
Well, yeah, because you're sending it to
You need
127
2
faculty
and you make a
members.
resume.
Yeah.
So you're just making copies.
You
Yeah.
can just send
Okay.
digital around.
Now, are you sending? And so you could send it digitally. But I get what you're saying. That's what I was asking. But let me ask you this: do we need 127 of each?
No, I was about to say like split it 63 and 64.
Okay. But do we know how many it's going to be ahead of time? Do we know if it's going to be 63 with John and 64 with Jennifer?
You could do a
Wait, but that can't
random
be
number
either.
generator maybe?
Okay. So remember, this is a completely randomized design. So you know what we're going to have to do? We have to use a random number generator. So what's the first thing we got to do?
Randomly generate numbers.
No, we got something before that.
Label.
Oh, we got to label. How are we going to label them, Serena? Because this is what you were not a fan of.
Label the
now.
resumes, label all resumes 1 to 127.
Unique label.
Label
No.
all,
Unique
all,
1 to 2.
all the,
Nope.
all the people, no.
We labeled the
The
experimental
researchers?
units.
Oh my
Yes.
Oh my
So,
gosh.
remember, we're going to label our experimental units, okay? So label faculty, science faculty members.
1 to 127.
There we go. Science faculty members. 1 to 127. Labeled. Done. Check. Okay.
Randomly
Why did
assign.
you just say label 1 to?
Label all science faculty members 1 to 127. Man, that air did kick on.
Yeah, it's rigid.
I like it this way.
Okay.
What's your color?
So after we label our science faculty members 1 to 127, what do we got to do?
Randomly assign.
Randomly assign.
Wait, I thought we already assigned.
No, random number generator.
So randomly
Generate numbers.
generate
Unique numbers.
how many unique numbers?
127. Yeah, 127, right? No.
1 to.
No. I'm gonna tweak out.
Is it not? What is it? It's not
So remember, 127 would be my entire sample.
2?
Divided by
No.
2. So.
Randomly
Oh,
generate
0.5?
64.
Can I do 68.5? I could
Yeah,
do
64.
63 or I could do
64.
64. If I have an even number that can be evenly split, use that number. But if it's 127, okay, randomly generate, I would accept 63 or 64. So randomly generate, let's say 63
Unique.
numbers. How are we going to generate those though?
With a calculator.
Now it doesn't have to be a calculator.
Random generator.
Random, yeah, so
It could be any random number generator. So RNG is heavily accepted on the AP exam. So randomly generate 63 unique numbers with a random number generator. Could you use a random digit table?
yes.
Yes. On the AP exam, and it just gets wonky, so I don't ever recommend it. You could talk about putting everybody's name in a hat, shaking it up, and drawing out
That's
63
crazy.
names. Yeah, it gets wonky. Like they always, like every time I grade or read for the AP exam, they're like, oh, but be wary if people word it this way with a hat. You know what they never have to do that with? Random number generators, because it's pretty straightforward, okay?
How long is the AP exam?
It's still 3
Good
hours.
afternoon, excuse
3
this
hours?
interruption. Teachers and students, there has been some revised times for the club pictures.
Bruh.
Please check the new updated list posted out. Yes, thank you.
Okay.
Why is it last minute?
Really quickly, before I forget to yell at me, I don't think I did attendance yet.
Dude, we're not gonna make it. We're
Yeah, Serena's never
Okay,
gonna find out.
randomly generate 63 unique numbers with a random number generator. Then what are we gonna do?
So if it starts at 8, then
Select.
3.
So we select when it's a sample, but what are we trying to do? We are trying to
assign.
assign, right? So assign the corresponding
Unique numbers.
faculty, because remember, we're corresponding those numbers to the faculty. To what? What are we going to assign those faculty members to?
To the unique number.
Well, we already gave them the numbers, right? We gave them numbers as we labeled them, 1 to 127. We randomly generated 63 unique numbers, But remember the study design. We're going to assign the corresponding faculty to what? To
Treatment.
a treatment, to the resumes, right? You're right, contextually it's the resume, but to a treatment. Does it matter which treatment? No, it's random. So let's say we assign the corresponding faculty to John's resume.
Wait, wouldn't it be better if you like, and then you flip a coin to see like which group they were in?
Yeah, you could do that too. You don't have to though, because you've already randomly generated these. So what Peter said is, would it be better if we then took a coin and flipped that coin to figure out which resume this group gets? Perfectly acceptable. You just don't have to.
And you could always show up to the exam in your graduation outfit.
Well, no, that's gonna be really.
So assign the corresponding faculty to John's resume, but I'm not done. I'm missing something.
Assign the remaining to the other group.
Yes, you have to then do that second part. You have to make sure you clearly assign the remaining to Jennifer's resume. So these are the principles of experimental design that Yale went through. We're almost there, I promise. We got 7 minutes, I got this. Okay? So label the science faculty members 1 to 127. Randomly generate 63 unique numbers. Assign the corresponding faculty to John's resume. Assign the remaining to Jennifer's. By the way, could I have flipped that and done Jennifer's then John's?
Yes.
You just have to make it clear that you're assigning one group to one resume and then the rest get the other resume. Okay?
Yep.
Yep.
Yes, sir.
So here's the way that they had it put in here. Let's see how well we did.
You got
Yeah.
7 minutes.
I got this. Get off me. So yeah, notice.
7 minutes, he got 6.
But
Oh, it is 6 now.
yeah, okay. Anyways, write all the numbers. So they did the slips of paper. There's some goofy things. Oh, sorry. Last thing I forgot. What is the end that we have to do? We have to compare. Remember, at the end of an experimental design, you always have to make a note about compare. I cannot believe I forgot that. Please notice, at the end of an experiment, you always have to discuss comparing the responses. At the end of the experiment, you got to compare the responses. Which is what we're about to do, Serena.
1 second.
Oh my gosh, what are you writing?
What are you writing?
Always compare responses.
Always compare responses. All right. So we did that. We did that.
That's what it says.
So please notice, like, here's the thing. You can write it out like this, but you can also just do it bullet point style on the AP exam, okay?
Oh.
I'll come back to all this because I know you're going to tweak out if I don't get there. I'll come back. All right, so here's the experiment results, right? So John's recommended starting salary from all 127 people was $30,238. Jennifer's $26,500. Average hireability ratings. John, was it out of 7 or out of 5? I thought it was out of 5. 3.78. Jennifer's 2.93. They had the exact same resume, but different names, different genders.
I'm
So-
offended.
Should be. So that's a difference of almost $4,000 a year and a difference of 0.85 on hireability. So does it appear from this data that there is gender discrimination affecting the gender gap?
Yeah.
100%, okay? Like, there's data for it. Now, I need y'all to hear me clearly on this. Just because there is data on this, there is evidence here. Is there a possibility that this was by chance due to the way we assign treatments?
Also,
yes.
Also, yes. Okay. Remember how when we looked at the curious case of Joy Milne, was there evidence that Joy Milne could in fact smell, I almost said Alzheimer's,
Oh my god.
Parkinson's, thank you. Was there evidence?
No.
I mean, yes.
Yes, like,
Remember, that she smelled 12 shirts, and how many of them did she smell correctly?
data.
Originally 11, it turned out all 12, right? But originally just 11 out of the 12. That in and of itself is evidence that she could smell Parkinson's. But remember how we then looked at that graph and we looked at the likelihood that someone smelled that many or more by chance alone. And it was like a 0.11% chance, right? That's next to nothing. That's almost impossible to happen by chance alone. What we will learn in the second half of statistics is to say, I clearly see evidence that there's discrimination. Is that enough evidence to say, yes, there is gender discrimination? There is evidence. Is it strong enough evidence for us to say, yes, there is gender discrimination?
I mean, it's like, it's unlikely that that much would be just because of chance.
Yeah, that's a
And
lot.
that's exactly what we're going to study, but we're going to learn how to quantify that with probability. We're going to learn how to look at probability and say, man, that is so unlikely, because all we have right now is data. We have the data that says, yeah, it's probably not possible. And I'm with you. That's probably not possible by chance alone. But I haven't proven it statistically yet. We're going to have to learn about, remember that term inferential statistics that was in the DYU?
Yeah.
That's what we have to learn in the second half of statistics. That's the number side of a lot of this that can help us out. So, right here, and they did in this study, so please notice this statement, the differences were found to be so significant that we said they were statistically significant. So extreme that they were unlikely to happen by chance alone. Okay? We still didn't prove it, but we found that it was so unlikely to happen by chance alone, we conclude there is what? Gender discrimination affecting the gender gap. That's what we need to recognize. We're going to have to learn how to quantify it, but please make a note of this because statistically significant is what allows us to make predictions about populations, is what allows us to make predictions about cause and effect. Statistically significant means that it was unlikely to happen by chance alone.
What job are they applying?
A lab assistant. But if you...
Dang, they do not pay a lot.
I know, right?
They could work at McDonald's.
No, for
Right,
real.
I think
They
you
got
get
that
more.
whole major.
I think you get more money from Chick-fil-A.
3.5 GPA
So,
for 30,000.
Again, final details. Since this was a well-designed experiment, we can infer, we can make a prediction that these average differences are caused by gender bias. Notice, I can only do cause and effect because we did an experiment that reduced the effects of confounding. I have forgotten to add these slides, but I will update the slides tomorrow. We will finish everything with experimental design tomorrow because we only have a couple things left. So be prepared for that DYU on Friday. We will wrap up experiments, as I said, tomorrow. We will start doing the review to get ready for a demonstrated understanding and a test tomorrow. But that does mean I would look at some of the check your understanding questions. I would go ahead and start making sure you understand the vocabulary. This unit, more than any